Afternoon, everyone. Today I'm excited to present our group project on handwriting recognition using deep learning. We have implemented a convolutional neural network CNN model to recognize Japanese characters from the KMNIST dataset. Our project employs various aspects of our model training and optimization, including different loss functions, learning rates, batch size, and an ensemble learning approach. Let me start by giving you a brief overview of our project structure. The main file, handwriting recognition .py, is organized into several key components. Handwriting recognition, data preparation and pre-processing, model architecture design, training and testing functions, performance visualization tools. Before we begin with the demonstration, I'd like to point out that the purpose of this presentation, we will be using what we call the fast mode to reduce the execution time. Let me show you the feature in our code. Just in these lines. With fast code mode enabled, our code reduced the number of training epochs from 10 to 5. Uses only 30% of the dataset for training and testing. Limits the numbers of learning rates within a reasonable time frame while still showing meaningful results. In a production environment, we would of course use the full dataset and more epochs for better accuracy. For our dataset, we're using the KMNIST dataset which are handwriting Japanese characters. Here is a load dataset function. We apply normalization to map picture values to the range, implement a subset sampling mechanism for faster experiments. Now let's look at our CNN architectures. Our model consists of two convolutional layers with ReLU activation and max pooling. The first convey layer has 32 filters, and the second has 64 filters, two fully connected layers with the final output layer, having 10 narrow of our classes. We have also implement comprehensive visualization tools. The plot matrix function shows how training loss and accuracies evolve over epochs. The visualize predictions function creates a grid display of model prediction of untested data. Correctly classified examples are shown in green, and while misclassification are in red. The matrix visualization are as the picture shows. In conclusion, this project demonstrates the effectiveness of CNNs for handwriting recognition and the value of systematic exploring hyperparameters. The ensemble learning implementation shows how even simple techniques can improve model performance without architecture change. Thanks for all of you listening to this recording.